Welcome back to the deep dive. We have a really interesting stack of documents in front of us today. On the surface, it just looks like, a standard certification prep kit. But when you really start digging in, it's more of a blueprint for how modern application delivery is supposed to work.
Right.
We are looking squarely at the 1Y0-342.
The 1Y0-342. It sounds like a license plate, doesn't it?
Yeah.
But in the NetScaler world, this is the big leagues.
It really is. This isn't the Hello World exam.
No.
This isn't what is a load balancer. This is really positioned as the gateway to understanding the advanced NetScaler configurations. We're talking high-stakes security, complex management, optimization.
Exactly. I mean, if the basic certification is about learning how to drive the car, the 342 is about learning how to rebuild the engine while doing 70 on the freeway.
And making sure nobody breaks into the trunk while you're doing it.
Right, that too.
So, for our deep dive today, we've got a specific set of exam practice questions, some technical specs around them. But I want to be really clear. Our mission isn't just to read you the answer key.
Oh, that's useless. Question 1, answer B.
It's boring, and it won't help you at 2 in the morning when something actually breaks.
Worse than useless. Memorizing an answer won't help you at all in a real-world scenario.
Exactly. So we want to unpack the logic. We want to understand why a specific feature is the solution. Get to that aha moment, So when you sit for the exam, you're not guessing. You're just applying what you know.
And speaking of sitting for the exam, we should probably set the stage. The facts on the ground, so to speak.
Yeah.
Looking at the specs here, it seems designed to induce just a little bit of panic.
Oh, absolutely. It's a pressure cooker. Let's look at the numbers. You have 75 minutes. That's it.
And in those 75 minutes, you're looking at what, between 60 and 70 questions?
So that's basically a minute a question, give or take.
Not a lot of time to second-guess yourself. And remember, these aren't simple true or false. A lot of them are scenario-based. You have to read a paragraph, diagnose the problem, and then pick the right fix in 60 seconds. You have to know it. It's about fluency.
Fluency is the perfect word, and the passing score is 65%.
Which sounds low to some people, but it's really not.
Not with this complexity. You've got performance-based tasks in there too, so It's a high bar.
For sure. And it's in English and Japanese, but honestly, the language of the exam is just logic.
Logic and architecture. So let's get into that architecture. We've organized our analysis today into 3 main themes.
Okay.
We're going to look at security, identity, and management, or as I'm thinking of them, the intelligent guard dog, the gatekeeper, and the architect.
I like that. It covers the whole life cycle of the traffic.
Let's start with the intelligent guard dog then. Web app, firewall, and security. This seems to be a huge chunk of the exam.
It is, because security is usually the #1 reason people buy a NetScaler in the first place. You have an application, it's on the internet, and you are rightly terrified of what's out there.
Which brings us to our first scenario here. Question 1. Imagine you're an admin. You have to apply security rules, but you're scared of breaking things for legitimate users.
The classic false positive nightmare. This is the biggest hesitation people have with a WAF. They're afraid of blocking real customers, killing revenue, so they turn it on but leave it in log-only mode.
Right. So the question asks, which feature lets the NetScaler observe traffic and recommend security exceptions? And the answer is the learning engine. Let's unpack that.
Okay, so think about the old way of doing security. It was a negative security method.
Oh, right, you had a list of bad things, and you blocked them.
But you can't list every bad thing in the world. The list is just infinite. The learning engine flips that. It uses a positive security model. It sits there, and it watches your legitimate traffic over time.
So it's building a baseline of what normal looks like.
Precisely. It learns what's good for your specific app.
Yeah.
And based on that, it recommends exceptions. It says, hey, I see this pattern all the time from good users, so maybe we shouldn't block it.
That is incredibly useful. It just takes the guesswork right out of it.
It does. And the key outcome here for the exam is that fine-tuning. It helps you tighten your policies while minimizing those false positives. It turns the belly from a blunt hammer into a scalpel.
I like that. So moving on to question 4. The reality is that the bad guys don't stand still.
It's the cat and mouse game of cybersecurity, always.
So the question asks, when should you update the way signatures? And the correct answer, which feels obvious but is so critical, is regularly to protect against new known vulnerabilities.
Right. And here's why that's so important. Signatures are your external intelligence. The learning engine we just talked about is internal. It learns your app. Signatures are external. They're about the world's threats. Think of it like a mugshot book at a police station.
If a new criminal comes to town and you don't have their picture, they're walking right past security.
Exactly. If a new vulnerability for, say, Apache is discovered this morning, your learning engine won't know about it. You need that signature update to tell the NetScaler, hey, look out for this specific piece of code.
So doing it just randomly or only when you reboot is not enough.
Not even close. The threat landscape changes daily. Regularly is the only way to catch those newly identified vulnerabilities. If you're 6 months out of date, you're wide open.
It's like trying to fight this year's flu with last decade's vaccine.
Perfect analogy. You need the latest data for the latest threats.
Okay, let's get specific on what these attacks look like. Question 8 and 9 deal with detection. 8 is about SQL injection.
The classic. It's a nasty one. You try to trick a database by typing code into a login box or a search field.
And the question asks how the WF detects this. I love one of the wrong answers here. By monitoring hardware temperature.
Yeah, right. My CPU is getting hot, must be hackers. No. If your CPU is spiking from a SQL injection, you have much, much bigger problems.
So the real answer is by inspecting HTTP request parameters. What does that mean, technically?
It means it's looking at the payload. The WAF inspects what the user is actually sending. It's looking for patterns, malicious signatures that look like SQL commands. It's essentially reading the mail to make sure there's not a bomb inside.
Okay, so that's looking at the content. But question 9 is about the source. This is IP reputation.
A totally different layer of defense. This is the bouncer checking IDs at the door before you even get in line.
So the function of the IP reputation service is what exactly?
It filters traffic based on a database of known malicious hosts. Think about efficiency. Analyzing every packet for SQL injection takes processing power.
You don't want to read every letter if you already know the mailman is a criminal.
Exactly. The IP reputation service just checks the source IP against a huge global threat database. If your IP is on a list of known spammers or botnets, you don't even get to the door. The NetScaler just drops the connection.
So it's hugely efficient.
Massively. Why waste cycles inspecting packets from an IP we already know is bad? Just block it.
So we have the learning engine adapting, signatures keeping us current, payload inspection catching the code, and IP reputation checking IDs. That's a solid defense.
It's a multi-layered defense,
yeah,
which is exactly what the 1Y0-342 wants you to understand.
All right, let's shift gears. We've kept the bad guys out. Now we have to let the good guys in. Theme 2, the gatekeeper, authentication and identity.
This is huge. And it's so much more complex now. It's not just username and password anymore.
Let's start with the visuals. Question 2 asks about the login schema. What's its main purpose?
The answer itself is pretty straightforward, but it's important. It defines the graphical interface for user input.
So it's the UI, the XML file that draws the login box.
It is. It controls what fields are presented. If you just need username and password, or maybe a drop-down for a domain, a field for an OTP token, the login schema dictates that layout.
Seems almost cosmetic, but if you get it wrong, no one can log in.
Precisely. And in a big company, you might need different schemas for different people. Contractors, employees, partners. It's about presenting the right door to the right user.
Okay, so once they see that form, there's a logic flow in the background. Question 7 brings up policy labels. This one can be a bit abstract.
It can be.
The question is, what component links multiple authentication factors together? The answer is policy labels. Help us visualize this.
Imagine a flowchart. Box 1 is ask for password. If they get it right, where do they go next?
Right. In the old days, they were just in.
But now maybe we draw a line to box 2. Check group membership. If they're in finance, we go to box 3, which is ask for duo push. If they're in sales, you would go to box 4, send SMS code.
And the policy label is the line connecting the boxes.
It's the glue.
Okay.
Policy labels let you link and chain policies together. Without them, you just have a flat list of rules. With them, you can build a decision tree with conditional logic.
That makes so much more sense. It turns a list into a workflow.
And the exam expects you to know that's the mechanism for that advanced logic.
Speaking of modern auth, we have to talk about the cloud. Question 10 is about SAML.
Security Assertion Markup Language. Can't do modern identity without it.
The question is, in a SAML setup, what role does NetScaler usually play for external cloud apps?
The key phrase there is external cloud apps. Salesforce, Office 365, that sort of thing.
And the answer is identity provider, or IDP.
Right. And here's why. You don't want your users to have a separate password for every single cloud app. It's a security nightmare.
Sticky notes everywhere.
Exactly. So the NetScaler acts as the IDP. The user logs in once to the NetScaler, The NetScaler verifies who they are, and then it issues a SAML assertion like a digital ticket or a passport stamp and hands that to the service provider, like Salesforce.
So Salesforce trusts the NetScaler, and the NetScaler trusts the user.
That's it. It centralizes authentication. Salesforce never sees your password. It just sees the ticket.
Got it. Okay, so we've secured the perimeter, we've built a sophisticated front door, but none of that matters if the system is a nightmare to manage or the user experience is terrible.
Which brings us to your third theme.
The architect. Management, automation, and visibility. This is the stuff that's often overlooked, but it's critical.
If you can't manage it at scale, you'll fail. Simple as that.
Let's talk scale. Question 3 introduces style books. What's the main benefit?
This is one of my favorite features because it solves the fat finger problem.
We've all been there.
You know, you type one IP address wrong, miss a comma, and the whole site goes down.
So the answer here isn't about speed, it's about configuration automation.
And specifically, creating standardized templates. Stylebooks let you define a gold standard for a deployment. You define it once, perfectly. Then you can deploy it 100 times, and it'll be identical every single time.
So it's about consistent, repeatable deployments.
Which reduces human error to almost zero.
Yeah.
You're not configuring everything from scratch. You're just filling in a few blanks on a template. It's declarative. You tell the system what you want, not how to do it.
That is the definition of working smarter.
It really is.
But even with a perfect config, things go wrong. Backends get slow. Question 5 brings up App QA.
Application quality of experience.
Right. Which feature is used to manage the user experience when a service is slow or unavailable?
The key is user experience. It's not just about load balancing.
So how is App QA different?
Well, standard load balancing sends traffic. But what if all the servers are struggling? If you just keep sending traffic, they'll fall over, and the user gets an error page, the dreaded white screen of death.
Right.
App QA steps in to optimize that response. It might queue the users, tell them you're number 3 in line, instead of letting the connection just time out. Or it might serve a custom "we'll be right back" page. It manages the perception of performance.
It's psychological damage control.
That's a great way to put it. It keeps the user engaged, even when the backend is hiccuping.
It buys you time and saves the brand's reputation. Speaking of disasters, question 6.
Certificates. The silent killer.
The question asks which tool gives you visibility into expiring certificates. We've all seen a major site go down because of this.
And your browser screams, "This connection is not private. It's a trust killer." All because someone forgot a cert was expiring on a Tuesday.
So the tool here is the SSL dashboard.
It's a single pane of glass. It shows you the expiration status of all your certs across all your instances.
Which allows for proactive management.
Proactive is the key word. You don't want to react to an expired cert. You want to know 30 days in advance so you can renew it. The dashboard gives you that visibility.
That's all the time we have for this deep dive. Good luck with your studies. Keep digging into those materials. You'll need it for those 75 minutes. And we will see you on the next one.
Good luck, everyone.